Now we're going to find the second derivative of parametric curves. So, we're going to use the equations from the first problem that we did to find the first derivative, and if you remember, that first derivative we got was cosine of t over negative sine of t. Now, the equation for the second derivative is the derivative of that first derivative, which is cosine of t over negative sine of t, over the derivative of the x. So dx dt in that problem was negative sine of t because x equaled cosine. So over negative sine of t. Alright, now we use some trig identities. So we know that cosine over sine equals cotangent, and since that sine is negative, it's going to be a negative cotangent of t. Now we can just find the derivative of this negative cotangent of t instead of having to use the quotient rule to find the derivative of cosine of t over negative sine of t. So we know that the derivative of cotangent of t is negative cosecant squared of t, but since this cotangent is negative, the derivative is going to be cosecant squared of t. So cosecant squared of t. Now we put this under this cosecant squared of t, so it's going to be cosecant squared of t over negative sine of t. Now we're going to simplify this, and to do this, we're going to look at this as if it's written cosecant squared of t over 1 times, well, we know that 1 over sine equals cosecant, so it's going to be times negative cosecant of t. We simplify this to get negative cosecant cubed of t, and that is our second derivative.